to the Lager Lecture Series, named after McMaster graduate Albert Abram Lager, a great believer in the value of lifelong education. He created the Albert Abram Lager Foundation, which supports several organizations in their efforts, including the McMaster Alumni Association. The United Nations 17 Sustainable Development Goals, SDGs, are a call to action to end poverty and hunger, protect the planet, and ensure healthy lives, peace, and prosperity by the year 2030. At McMaster, we recognize our responsibility to address these goals as we work together, across disciplines and faculties, locally and globally, to create a healthier, brighter world. In 2022, our online Lager Lecture Series will feature talks by McMaster researchers, projects, groups, and alumni to showcase how McMaster is helping to reach these goals.
Good evening and welcome to this Lager Lecture Online. My name is Jessica Lounsbury and I work in the Office of Alumni Engagement here at McMaster. Over the next 2 years, our Lager Lecture Series of webinars will feature talks on some of the research taking place at McMaster that is helping reach the United Nations 17 Sustainable Development Goals and their targets. This evening's lecture will focus on Sustainable Development Goal 13, Climate Action. As guest speaker and Faculty of Science alumnus, Dr. Sean Carey will discuss how our North is changing and what it means. Dr. Carey is professor in the School of Earth, Environment, and Society and directs the Watershed Hydrology Group. His research interests include hydrological and land surface processes in natural and human impacted environments. He has a particular interest in the processes that are affected by cold temperature and working in northern environments. If you have a question for Dr. Carey this evening, please type it in using the Q&A button at the bottom of your screen, and we'll have some time to answer a few questions at the end of the formal presentation. So without further delay, please join me in welcoming Dr. Sean Carey.
All right, thank you so much, Jessica. I'm just going to share my screen here, and hopefully this works. It typically works because I've been doing this for a couple of years now. So if I don't hear anything, I assume you can see the screen. And at first, I'd like to thank everyone for joining. And yeah, I'm sitting here in my office. You can see behind me, there's scaffolding, and my entire building is covered in tarps, so I don't have much of a view, so my lights are on. But it's the evening, it's the April 6th, and you know, I want to give you a bit of a, I guess I'd call it almost a fireside chat of the research I'm doing, how it relates to sustainable development goals, and sort of what it means to me. And I'm sitting here in Hamilton. It's the traditional territories of the Anishinaabe and the Haudenosaunee. I have know Mark Hill, the Chief of Six Nations, quite well, and I've worked with him over the last few years on a number of water issues. But I'm going to take you away from here. I'm going to bring you to the north of Canada, where I've worked with folks for almost 25, 26 years now on these research questions. So I'm going to give you this view of what I've seen over the last, since 1994-5, and what it means for the future and how it sort of relates to what my research program does, my colleagues do, and the UN Sustainable Development Goals. So again, thanks very much for showing up, everyone, and sit back, hope you're relaxed. And with all these sort of talks, most of my sort of I just want to tell a story. I think storytelling is one of the most important things scientists do, and I want to show you pretty pictures because I've been in these beautiful places, and it's kind of not fair to keep them to myself. So what would I like to share with you this evening? I'd like to tell you about my journey at McMaster. I came here in 1994. I did my undergrad at the University of Guelph and came here and did both my master's and PhD. And yeah, so I'm going to tell you about my journey. I'm going to talk to you about the beautiful, how north of Canada is so beautiful and what some of its pressures and challenges are. And I also want to probably give a little bit of, I don't know, I guess commentary or my perspective on, Canadians' commitment to science, long-term science observations, how we interact with Indigenous peoples, and sort of where science is now and where it was when I started, and how a lot of the work that we do in environmental sciences and earth sciences doesn't generate apps, likes, or shiny things, and it doesn't happen on political timescales, but it's really important. And finally, and I want to talk to you about communication and how us as scientists communicate. The climate crisis is a water crisis. I'm a hydrologist. I'm mostly considered, most of my interests are in all things watery. And yeah, if we look across Canada, there are a large number of water crises. Climate change is most clearly manifested in water. And there's large programs in Canada that I'm going to talk about that like to solve these problems, but I'm only going to touch on just a small few. And those are ones particular to me in the northwest of Canada, in the Yukon, where I've spent, where I spend much of my time thinking about and spending time on the land. So that's where I'm going to bring you. But I just want to let you know that when we look at SDG 13 and the Sustainable Development Goals, they apply all across Canada. I thought this picture would make people laugh. I don't know. Maybe my parents would check out this talk. I doubt it. My family's a long line of pipe smokers, so I just thought this was funny. I first went to the north in '94. I worked with a fellow named Dr. Hawk or Minko Wu, Hawk Wu. He was my PhD and master's supervisor, and he infected me with this love of the north. I've been around Canada. I've actually traveled around universities quite a bit. I was the first at University of Saskatchewan, which was a wonderful way to start my career, and I met some lifelong colleagues. Went to Carleton University in Ottawa for 7 years, and I came back here in 2011. I'm a dabbler. I think I'm kind of everything kind of environmental interests me. Sort of water is my home base, but I do a lot of work with climates and biogeochemistry and all sorts of things. And I also do a lot of work with industrial with large scale resource companies, whether it be oil sands or coal, et cetera. I have a whole other hat where I try to look at problems, environmental problems caused by development, and try to help. And I'm a dedicated dabbler, but most of all, I'm very lucky. This picture, not many people see. I'm swallowing the rainbow. I've been lucky enough to travel all these beautiful places and do all these wonderful things I'd like to share. It comes as no surprise, and this is always the doom and gloom sort of part of the story. And I don't really necessarily want this story to be a doom and gloom, but as I was putting it together, it's very harrowing, some of the things I've seen and some of the things I want to talk about. But the North is warming fast. It's warming faster than anywhere on the rest of the planet. And, there are areas in the Yukon where I've been that over the last 50 years have warmed several degrees. And even in the last 20, 30 years that I've been there, it's warmed a degree. And it's really, it doesn't sound like a lot, but it's really, really notable. There's a polar amplification of warming. The Earth sort of projected wrong. The top of the Earth is actually quite small. And if you look at this thing on the bottom, I don't know if you can see my cursor, it doesn't really matter. As we move farther north, it's really warm. You've probably heard recently Antarctica has smashed its temperature records as well. And yeah, so this is what we're living with. And sadly, these are old ones. They've changed the scenarios, but they don't look any better. Under business as usual, our social pathways now, however, we sort of want to deal with the global carbon emissions. The picture of these models aren't good. I'm not going to talk about models. I'm going to talk about real life today. But if we look in the future, casting out 30, 40, 50 years, again, this is old 2016 to 35, the North is continuing to warm. And it has consequences of fire and drought, et cetera, but the North is a bit peculiar. So that's, again, what I want to talk to you about. What you don't hear as much about is how it's getting wetter as well. With climate change, warmth increases wetness simply because the air, as it warms up, can essentially hold more water. And they call that the acceleration of the hydrological cycle. And in the time that I've been in the Yukon, it went from what I would consider a very dry, arid place to one that isn't so dry anymore. And it's something, as I say, since I've been traveling up there every summer and most winters, it's wetter, and it's getting wetter every year, and it's actually remarkable. In the last few years alone, there's been all sorts of major records broken. I was just in Yukon a few weeks ago. Last year was the most snow they've ever had on record. This year is now the most snow they ever had on record. Last year was the highest flows they've ever had in the river and the most flooding. Who knows what it's going to be like this year? It's still winter. And just an example of, if we look on the left, this is just everywhere blue means more than normal. And these numbers are saying the percentage more of snow than is usually measured at these sites over the last 50, 60, 70 years. And so some of these sites are over 200%. And that means there's twice as much snow. And that means the chances of flooding is twice as much and has all other implications. Here's a picture of one of our sites. That gauge is 8 feet high, and we're looking down into it, and it's measuring precipitation. And it's something that isn't sort of talked about so much, but measuring precipitation, understanding precipitation is super hard. It's really easy to say how temperature is warming, but how precipitation changes is just one of the most vexing, difficult things that we deal with as hydrologists. And I'm just showing this video because someone sent it to me. It's one of the sites we work at, and we measure precipitation 14 different ways at this site, and it's just one site. and it's really hard just to measure. And then we have to measure it over these massive areas of the north that aren't being measured. So we simply don't know how the north is changing. Temperature is actually really easy. How it's going to get wetter or drier is something that is hydrologists, and from a climate point of view, is still one of the great sort of unknowns and something we have to learn to adapt and mitigate and deal with. Oops, there we go. So it's change. I work in a department called, we change your name all the time. I'm not sure what that means. It tells me, ask my, I don't know what it means, but we are now the School of Earth, Environment, and Society. And I have lots of interesting and fascinating and wonderful colleagues. I have folks that are geologists who look at the Earth and think of it's 5 billion years old in its history. I have friends who are interested in urban aspects and social aspects of the world. Change is the norm. It's not the exception. There's change that happens all the time. When we talk about climate change, some of my earth scientist friends say this is a blip. You know, it's very short on their bandwidth, and that's fair enough. But you know, in human times, in the last, say, 10,000 years or 5,000 years, the change that's undergoing now is unprecedented. It's going really fast. There's rapid, ample photographic evidence of the real environmental change that's happening. These are just pictures, and there's lots of projects now that are going that are underway to go back and take repeat photos of these old photos we have. And they're all over the internet now. And they're just staggering how we've lost so much of the cryosphere and how vegetation has changed and things are very different. There's all sorts of reasons to cause it. A lot of it's land stewardship and land management and changes in practice when the settlers came to North America. But one of the big thing is simply, you know, in the north, it's changed. I got a note that says, can you please enlarge the slides and reduce the speaker's image? I don't want to be too large, so I don't know how to do that. I can't even see myself. All I can see is the chat. So if our what's it called? Tech support can do that, that would be great, because the last thing you want to do is see my big face and not much of the pictures. I don't know how many of you here tonight have been to the north. And if you haven't been to the north, I'd recommend you to go. I noticed that the Yukon advertises on hockey games now. There's lots of commercials that you see all the time, and what you see will amaze you. It's simply the things that you see in the north or are just, you know, sometimes undescribable. I actually put this photo up and asked people what they think they're seeing, students what they think they're seeing, and most of them I think have watched Game of Thrones and they say it's the wall. I think that's great, but it's not necessarily true. And I'll talk about it a bit in the things that we'll see in some of the facts and how we look at nature and stuff. So I'm just introing this up to set you up to talk about what my students do. It's not really what I do anymore. I think as a professor, I have the luxury to work with amazing, smart, wonderful, dedicated, enthusiastic, you know, ever suffering, I suppose, graduate students, undergraduate students who allow me to sort of chase these problems and to look at environmental change in the north. The one thing that I want to talk to you roughly is about all of these issues kind of in sequence. And I talked already about changing precipitation. I want to talk how we're losing the cryosphere. I want to talk about vegetation change. I want to talk about thawing permafrost. I want to talk to you about, as I say, the journey I've had doing this kind of work and what I've seen in the time I've been in the north. Okay, so this is the thank you slide to the people who've paid me. I have worked over the last long time to try to keep my research going. And most scientists complain about this. I don't complain about it because I feel very lucky to be able to do the research I do. There's a lot of people who fund the work that we do. I've been working at this place called Wolf Creek, which I'll talk about briefly, since, again, you know, I first started doing research in the north, and different people have allowed us to do this research and keep these long-term observations going. It's very, very difficult to keep observations of the environment going because it's not very engaging. It's not very gripping. Dare I say it's not very sexy, because it's often, you know, scientists say, oh, it's just monitoring, it's not science. But I think careful observation of things over long periods of time enlighten us in ways that we often don't understand. And lately, I've been part of this program called the Global Water Futures Program. It's the largest, it's kind of nearing its end. It's got a few years left kicking, but it's the largest university-funded water network in the world. It's led by the University of Saskatchewan, but McMaster is one of the former partners, along with Waterloo and Wilfrid Laurier. And it's a massive, you know, 100 and some odd million project to really look at how we're understanding water, how we're communicating about water, and how we really have solutions to deal with climate impacts on water. Global Water Futures is a different program. And what I want to also do tonight is talk about communication, because I've worked in a lot of places for a lot of time. I sit around campfires with people, I sit around drinking coffee and other things. And only recently have I sort of opened my eyes to other ways that we can communicate science. And I think that as scientists, we've sort of missed out on. And so tonight I'm going to show a number of pictures of my friend Gennady. Gennady's a Norwich, England-based eco artist. He's a real artist. I don't know too many real artists. Gennady's a really fascinating fellow. He does all sorts of mixed media. He does music, et cetera, et cetera. And several years ago, we asked him to come with us and kind of hang out with us in the field and show the world what he saw through art. Global Water Futures supports a number of artists to do water-based art. You can just search Global Water Futures virtual water gallery and you can see different things. Actually, Gennady's up there in the toque on this big, massive pastel. But yeah, so I'll have art interjected into my presentation with photos, just because simply sometimes the way the artist sees the world has an impression to it that that photographs and certainly figures and graphs don't have. That's for sure. All right, so where do I want to take you? I want to take you to my home, my spiritual homes. The first is this Wolf Creek Research Basin. Wolf Creek is a creek just south of Whitehorse. It's quite big. It's about 170 square kilometers. It's there's a campground at the outlet, and in 1992, a friend of mine who's deceased decided that we didn't know anything about the North and the hydrology of the North, and just implored people to come north to study it so we could understand change, because they couldn't get the floods right, so there was loss of infrastructure, et cetera, et cetera. So Rick, who I'll introduce later, set up this research basin. The creek actually ran through his backyard, which is very convenient, and then slowly and surely people started coming north. And I arrived there as a very young man and have never left. It's a place that's sort of taken my heart. There's Gennady's painting of the place on the right. Here's a photo from a helicopter on the left. It's on the traditional territories of 3 First Nations. It's quite large: Squanadun, the Tachin Council, and the Carcross-Tagish First Nation. And we work with them all. You know, to do research in the North, you really have to work with Indigenous communities to get research licenses, do fireside chats, et cetera, et cetera. So we share all our results with them. We have sort of collective meetings, and this is where my learnings and my story about climate change and water sort of begins. It's a beautiful place. As I say, just some pictures are worth 1,000 words. That no matter when I go, it always stuns me, and it's always a breath of fresh air when I get off the plane and get on a snow machine and or an ATV or a truck and get up into this watershed and think about my science. It's always something that makes me realize I know why I'm doing what I'm doing, and yeah, and it's probably for something greater good than just me. I'm also going to take you to another place, which scarily may be more beautiful than Wolf Creek. In the last 3 or 4 years, I've been working farther north in the Yukon. We were asked to work up there because climate change was more rapidly occurring farther north. And it's up along this Dempster Highway. It's the Canada's largest northern highway. It's sort of falling apart. And there's one territorial park there called the Tombstone Territorial Park, and we've sort of set up a number of sites, and we call it the Tombstone Waters Observatory. 2, because Wolf Creek was 1, so this is 2. And again, it's a stunningly beautiful place. It's much colder than Wolf Creek near Whitehorse. There's lots of permafrost everywhere, which I'll talk about. And it's a beautiful environment that's slightly different. And it's on the traditional territories of Trondequitchin, and they've been wonderful hosts. And they're really excited about the work and the partnerships we do, simply because they have lots of real sort of concerning issues, regarding water quality and flooding, et cetera, I'll talk about. All right, so what do I do? Well, the picture of me on the right is me in 1995 or 6, which is kind of scary. All I do, and all my students do, is observe things. We go in with hypotheses and ideas of what we're going to see, but what we do is we try to measure. I make a joke to my students. I say, we're going to measure everything all the time. We want to measure where all the water is. We want to measure where all the water leaves the catchment. We want to measure evaporation. We want to measure the quality of the water in the stream. We're really trying to get comprehensive, integrated views of the environment and of the changes in the environment. So every year we travel north and we have different specific projects to understand processes, but we go and we simply camp out and we measure and we look and we do experiments, and year after year after year, we carefully record what we've seen. We share our data as much as possible with people. And then we enlighten people about how the North is, what the processes are, and how it's changing. So what my science is about in the North is about a long-term commitment. I hope to never leave. Maybe, eventually I'll retire and maybe I'll build a house in these areas. But this is sort of what I do at McMaster. I'm not a McMaster's got lots of medical people. I'm not saving lives or doing anything that's sort of perhaps too fascinating. But it's this long-term legacy of observation that and understanding that I'm trying to contribute to, and again, as part of this SGD. So what's happening? I was just there. This was a picture I took. It was one of the coldest I've ever been. It was minus 35 and the wind was 100 kilometers an hour. This is a massive Arctic windstorm. And I was kind of concerned it was so cold, but it was such a beautiful photo with the sundog, I thought I had to share it. This is what most people ask me about when they talk about the North. It's this issue of permafrost and permafrost thaw. Permafrost is a term, and it's relatively sort of generic definition. It's ground that's frozen more than 2 years. And it's not just frozen water. It could be any sort of material that's frozen. It's frozen water, it's frozen soil, it's frozen rock. It's just permanently frozen ground. And if we look at the circumpolar picture here, we see very kind of large areas of Russia, Alaska, Canada are under different areas of permafrost, including the Tibetan Plateau. Continuous, discontinuous, and sporadic permafrost are just the colors. And this just says, is it totally under permafrost or is it permafrost in certain areas? And Wolf Creek and 2 are represented right here in the southern Yukon and kind of central northern Yukon. This is a picture of a permafrost core. And you can kind of see in the core, there's rocks, but there's a lot of water in there as well. That's ice. And this is sort of where people get really sort of anxious about the permafrost thaw. If it was just rocks and just stones that thawed, we probably wouldn't hear so much about it. But the problem is the water, the ice is changing to liquid water. And because of that, we have a lot of sort of consequences. And one of the most common consequences is this process called thermocarst. Thermocarst, essentially, karst is this, actually Hamilton's on a karst landscape. It's this erosion caused by water. And what happens is when the water in the permafrost thaws, the land loses its stability. The water essentially, for the ice, is the skeleton which the land is holding itself up upon, because it's very, very, very ice rich. After millennia, ice moves into the pores. So much of the ground isn't rock, it's rock and ice. And so when the ice thaws, all of a sudden the landscape collapses. Permafrost changes in thickness. If we go very far north, it's super, super thick and we don't have to worry about it. But the environments I'm working in are these more southerly ones where permafrost is sporadic and discontinuous. This is where we're losing the cold fast, where temperatures are near zero. And this is where the landscape quite simply is changing before our eyes, because every year we have thaw. And once this happens, it's very hard to stop. And the consequences you'll see are big, and sometimes they're irreversible. I mean, when things are sliding into a lake, you're going to affect the water quality. When you have a highway that was on permafrost and no longer is having permafrost, you're going to spend a lot of money keeping it going. We have infrastructure. This is an old building in Dawson that's falling apart. This is a picture by Jürgen van der Sluis, who works for the NWT government. It's a drone image of just, permafrost thaw on the Dempster Highway. This is another Dempster Highway photo near 2. These things are really hard to keep going, because as we warm the climate, this permafrost is thawing and there's really nothing we can do about it. And it's very, very, very hard to stop. So the one context we know is that permafrost is thawing. There are permafrost scientists. There's courses in permafrost. When I went to Carleton University, I was recruited there by a fellow named Chris Byrne, who's a really famous Canadian permafrost scientist. And this is what they study. And I'm not a permafrost scientist. I'm really interested in permafrost, but I kind of want to know what happens to the water and other things associated with the water when the permafrost thaws. This is, again, a picture of the Dempster Highway taken from one of our drones by sort of a researcher of mine, David Barrett. Just a beautiful, there's this watershed in here that we study. And so, yeah, so this is the questions that motivates me and my students. These are some pictures because I think they're really funny. Science has changed a lot. In 1996, my supervisor, gave me a wad of cash, some instruments, a helicopter ticket, and they dropped me off in the middle of Wolf Creek with my field assistant, Roger, where we stayed for 4 months. So most of my early research, and this was my PhD research, Basically, I was interested in, and not a lot of work had been done on this back then, was seeing how permafrost and frozen ground basically influenced the amount of water, where it was going in the landscape, the quality of the water, et cetera, et cetera. So I sat there for years, actually, for 3 or 4 years. I sat out in the snow and I traipsed around all seasons long. Here's my tent. We even had laptops back then, even a printer. They didn't look so good. It looked like I'm sunburned, and tried to do this. And the amazing thing is back then, how little we knew. And the amazing thing back then is my supervisor was, I'd come back to McMaster after 3 or 4 months in the field. I'd grown my first beards and sort of had my first sort of, lonely experiences, I suppose. And I'd come back and he would say, well, Sean, what did you see? And these are drawings that my PhD supervisor would do as I was talking to him and trying to distill all the environmental observations. And we were using scientific instruments, et cetera, et cetera. And what I would do is I would just sit down in his office and he'd yell at me for a while. And I would just talk about what I saw and he would draw it. And I would say, well, these areas with permafrost, these hill slopes with permafrost that are really cold, there's all this water that's coming off. And he would say, when? And he'd say, well, in the winter, this is what's happening. In the spring, this is what's happening. And I'd say, these areas without permafrost, the water disappears and the groundwater is changing, et cetera, et cetera. So way back in the 90s, this is what I was concerned with. And I was just putting together and piecing together with folks in the US and in other cold areas, putting together ideas of how these landscapes worked. And since then, it's developed really quite rapidly. When I was doing my PhD, we talked a little bit about climate change, but it wasn't sort of the reason we were doing it. But really rapidly, as my PhD was finishing around 2000, even though we knew about it, people realized that things were happening very fast. And what the consequences of permafrost thaw essentially are this. And this is a picture from a former postdoc of mine, Barrett Krylik, and Michelle Walvord, who works at the US Geological Survey. And all they're trying to do is saying, what does permafrost do? Permafrost stops water. If we thaw permafrost, water can go where it didn't go before. So there's this area above permafrost called the active layer, which freezes and thaws each year. But as it's thawing, water can go places. And if water can go places, it can mobilize chemicals, it can change the way water flows in the river, et cetera, et cetera. So over the last 20 years, we've realized that permafrost is changing, and it's changing fast. There's not a lot of things. I've been around Hamilton a long time. It kind of looks nicer than it used to. It's revitalizing, et cetera, but the environment isn't changing. A lot of these places in the north, the environment's changing before our eyes, both physically, and the water's changing. As we thaw this permafrost, groundwater flow that we don't see beneath the surface interacts with rocks and soils and sediments that were previously frozen. Because we've been there so long, we've often gone back and redone experiments we did 15, 20 years ago. And there's this one, it's a mixture of chemicals. It's called dissolved organic carbon. It's really a relationship or function of how much organic material is dissolved in the water. And it usually means the water's flowing near the surface. So I had a PhD student a few years back go and repeat some experiments we did a long time ago, just for the spring. And you'll just notice, that's Nadine down there, and Heather, her field assistant, reaching into the stream that's frozen. We've had this massive decline. Like, it may not seem that much, but if you look at these boxes, we've had this decline, and the decline is because of thawing permafrost. Water is moving deeper in the landscape, and we're changing carbon. You may not think this is important, but the chemicals in the water affect the mobility of contaminants. They affect the stream temperature. They affect how much light penetrates in sort of the biological aspects of the stream. So these subtle changes in permafrost have these massive knock-on effects. And we're working with the Trondequitchin folks because they're really concerned about thawing permafrost, which is natural, and it releases uranium and arsenic. And so this is a couple of my crew here, and I get to take beautiful helicopter rides into these streams in the middle of nowhere to take water samples to measure for these geogenic contaminants that are just naturally being released into the environment at levels that are really, really toxic to human consumptions, potentially in streams that Indigenous people are taking water from. This is a natural consequence of climate change. Uranium and arsenic are naturally in sort of certain rock formations, but it's something that is now occurring because of climate change. Stream temperature, chemicals. I have students doing this. I have two students, Arsh and Anders here. They just went to the Yukon last week. I just wanted to give them a shout out. They're both doing their PhDs. Anders is very concerned with how stream temperature is changing, which is hugely important for fish and habitat. And Arsh is much more interested in chemicals and how they're relating to permafrost. So watch this space or my space or whatever, the web space for their research as we sort of develop over the next few years. The North is changing, not just chemically, but the flows in the river. There are flows in rivers that never flowed before. The Arctic has a very distinct hydrograph. There's a hydrograph here that shows there's no flow in the winter, the snow melts and there's this flow, and then it goes through the summer. But I had a really clever PhD student named Victor Tang, Weigang Tang, and he spent a lot of time looking at all these publicly available data sets which are used to assess climate change and look at where the change is occurring. And what Victor's shown, and other people have shown as well, and Victor's shown it through all sorts of deep learning methods and just classical hydrometric methods, that winter flows are increasing and they are occurring where they never did before. And the reason this is happening, again, is because the groundwater is thawing, water is moving through the subsurface and getting to the stream where there was no water getting to the stream before, which is kind of remarkable. And if you talk to people and they're like, there was no water before and there's water now, yeah, it changes all sorts of things. It changes your ability to traffic surfaces, et cetera, et cetera. I just want to show a picture of Victor. We brought Victor to the Yukon because he works with all this data. And there's this cat who I think has since passed away, Elliot, who would claw you to death if you got up. So there's Victor looking happy, but he's done a lot of this work to just show physically all the flows in the river are changing. The seasonality is changing. It doesn't matter where we look across the Arctic, it's changing. We look other places, we can't really see the change that much, but in the Arctic, it's manifested completely. And it's a whole different water environment, again, which has these other effects. Even in Wolf Creek, I had a student, she's now at ENRS in Quebec, look at Wolf Creek and how it's changed since 1992, which isn't very long. Same thing. The green just shows significant increases in the winter. Every year we're getting more and more water in the stream. Precipitation's changing, but mostly it's in the winter. And this is sometimes we can't get students up there, so we enlist whoever we can. And here's a nice little labradoodle taking a stream flow measurement for us, who's a dog of a field researcher named Dave. So. And yeah, so wherever we see it's changing, and it's not stopping anywhere. Other things that happen, I don't know if anyone in the audience has been to Dawson City. Dawson City is an amazing historical place. It has amazing long-term records because during the gold rush in sort of 1897, 98, there were 50, 60,000 people who came up to, get rich. And because of it, there's been lots of long-term observations. And one of the greatest long-term observations is that they put a tripod out on the ice every year. And there's a large amount of money that's waged to see when the ice goes out. And if we look at this, and I just pulled this from yukonbreakup.com, the date is very subtle. It's getting earlier. Some of these dates down here recently are very early, very, very, very early. But there's a general earlier sort of ice breakup. And kind of the consequences of some of this can result in flooding. This is a picture of Dawson over here. And when the ice comes up, people get really crazy. But some years when the ice backs up, they built this big berm and we have this sort of new floods that we didn't have before. It creates all sorts of problems. And I wanted to show this picture. I don't know if any of my students are on it, but this is a very famous hotel in Dawson called the Downtown Hotel. And I don't know if anyone has heard about this place, but that's the place where you actually go to kiss a dismembered human toe. And most of my lab mates have to do this. And that was a picture of me kissing it. That's the sour toe cocktail. The person who I want to dedicate the sour toe cocktail to is my dear friend who's passed away. Rick Janowicz. Makes me sad thinking about it because he was a Yukon's flood forecaster for 35 years. He was a dear friend of mine. There's outside the fire hall. There's in Dawson, there's a memorial to him that you may want to see if you ever get there. Dedicated flood forecaster protecting the lives and livelihoods of Dawsonites from 1982 and 2018. And he went there every single year to just sort of help communities across the Yukon sort of protect themselves from this climate change. And Rick was a kind of an interesting soul who did a single person who did a job for 35 years. He was the only flood forecaster for all of Yukon. So he had more traditional knowledge in terms of this than anyone. And he was he still actually is impossible to replace because of all the knowledge that he had through the years. Again, Gennady interpreted this, Ice to Water Too Soon, a painting that he made. Field pastel, he would go and sketch this up. The regimes of the North are changing before our eyes, and even influencing artists. Okay. Other weird things that happen when we lose permafrost is that water moves in the winter where it wasn't supposed to move before. This is again a drone photo from the Dempster Highway. There's one of our field trucks. This is all ice, which is remarkable. What's happening is because groundwater is flowing all winter long, we used to stop flowing, but now it's flowing because the permafrost is thaw through these things called talics. We get all this massive ice buildup in the stream. And here's a culvert across the highway. And that culvert's full of ice. This is probably June or something like that. It's me from a few years ago. And I had a student I'll talk about in a few minutes, Aaron Nichols, make this movie. And we just put a game cam up, and we weren't like hunting or anything like that. And we just wanted to see the processes that were going on now that were never before. And you'll see we're moving in October here. It's going to move in November and December, get really cold. And even though it's well below zero, what's happening is there's still water moving beneath the surface. Even at minus 30, water squeezing out of the ground and squeezing out of the ground. And it's just under so much pressure. And what happens is that culvert's no longer good. When it floods in the spring, highway washes out. It's amazing that every year, the Dempster Highway costs more and more and more money to repair. They have to put heating cables to melt the ice. Here's the 3 culverts. They don't look like they're very effective. So the Yukon has to spend hundreds of thousands of dollars every year just to create and melt little holes in these culverts where they used to be operational. We're working with them to try to understand these processes better, but again, it's a consequence of climate change to the north and the built infrastructure. More commonly, we know of floods. No matter where you go in the north, floods are increasing. It's amazing how they put these massive culverts in and they get washed away. Here's a next picture. Here is a picture of these 4 big culverts on the stream, which often goes dry. When it rains, it now rains really hard. It rains harder than it ever has before. And each year on the Dempster Highway, they increase the average maintenance costs $400,000 a year every year. So the highway used to not cost very much money to maintain. And now because of these natural climate disasters and hydrological knock-ons, basically it's becoming so expensive that there was even talk about the Yukon not really wanting to keep the Dempster Highway open because it really is to serve the Northwest Territories and Nunavut and Tuktoyaktuk. Doesn't do Yukon's economy much good other than a bit of tourism, but just the cost of keeping it open is so expensive because of this changing climate, changing environment. Pretty fascinating stuff. And last year in Whitehorse, as I mentioned before, it was the biggest floods ever. It was the highest flows ever. They didn't actually know how much water was in the river because they never had flows that high. The dam had all the penstocks open. They were releasing all the water they could. And we were there in August, and this was August because the glaciers were melting. There was a lot of people who were very, very tense. And they'd called in the army, et cetera, et cetera. You probably didn't hear about this, but this was blew past all the records. And I was just on the call with some of the Yukon flood folks earlier this week, and they're not worried yet, but they're starting to worry. And again, this is now the norm. It's not the exception. And it's something that we have to adapt. And it's very hard to adapt to something when we build infrastructure that reflected a climate and a hydrology of 20, 30 years ago. Pretty much one of the last things I want to talk about is something that's kind of remarkable. It's something people don't think about. And it's work of a PhD student of mine, Aaron Nichols. And Aaron's been going to the Yukon since 2018. So she's in the final throes of her thesis. And when she started thinking about what she was going to do for her PhD, there were a number of topics on the table. And the one thing we noticed that people hadn't really talked about was the impact of how changing vegetation actually influenced the hydrology of the north. People were all of a sudden, they were all over the permafrost thaw. That was sort of all the cool kids were doing that. But more and more observations were showing that, man, the environment's changing. And these are actually very recent. It was like long after Erin sort of started her PhD, showing that the north is changing. Its greening tree line is shifting. There's a huge proliferation of shrubs. And this is, no matter where you go in the north, this is the number one kind of environmental consequence to something called shrubification. We're not biologists. We've actually started playing with biologists because we have a lot to learn from them, and they know a lot more about plants than we do. We used to think plants were trees and bushes. Oops. And we set up this instrument in 2001, and quickly the shrubs overtook it. And we didn't know why. When it first started happening, we thought we had put our instruments in the wrong spot. But as hydrologists, we didn't realize that plants grew, which they do. And they were growing in response to climate change. They hadn't grown in a long time, but they'd really, really started growing up. And so we keep these instruments in place as a historical legacy. And we brought Gennady to it, and he put this picture, and this one actually hangs in my office. And these are supposed to be the fire of the shrubs and overtaking our meteorological station with a mountain in the background. But this shrubification is something that's dramatic. It's all across the Arctic, no matter where you talk, in sort of the subarctic anyway. This is what we see. I had a master student a few years back, Sean Leapy, and he used what we call LiDAR. And LiDAR is in our phone now. It's sort of in our cars. But we fly these planes, and they sort of can look. I don't know why my thing's advancing, but it's saying hurry up probably. They can look down, and it shows how much more shrubby it is now. And if you look at just between this 11 years, these are shrubs over 45 centimeters. It's this massive proliferation of shrubs. And this has massive environmental consequences. And this is what Aaron was taking a look at. And when we kind of sketched it out what it was almost everything. It changed how bright the surface was. It changed how much precipitation fell into the canopies. It changed the whole energy dynamics. It changed the ground temperature, which affects all sorts of biological issues. It changed how much snow and evaporation. So Erin marched off and spent years and years in the Yukon, and she did all sorts of cool things. She had a number of sites that she wanted to use what we call a space for time analogy. So what she did was she looked at kind of low shrubs and more shrubs and forests. And then she hooked all these plants up to sensors that measured their sap flow. And she was really trying to understand the role of what these plants were doing and how these plants were modulating and affecting this climate change, because tree lines marching up, tree lines getting farther north, it's moving up the mountains, and the shrubs occurring. And there'd been almost no real research on the hydrological consequences of this climate change phenomenon of rapid greening, which is happening much faster than permafrost thaw. Beautiful picture from the forest. Each one of these forests basically has I don't know what you'd call it, like having its pulse checked, right? There's sort of needles in the tree that's measuring how fast these trees are moving water up. And then we sort of move these things to the landscape. But the first thing Erin showed me in a paper that she published last year was, if you go from a landscape like this to this, it gets much darker. And it may not seem like a big deal, but if we go from a landscape with sparse shrubs to one with big shrubs to one with forests, the albedo essentially is how reflective it is. In the winter, it becomes much less reflective. The consequence of that is that climate will get warmer. That means that more radiation is absorbed at the surface, which will warm the air temperature. We hear about this with sea ice and the loss of snow all the time. They say the ocean gets darker, the sea ice melts, it's going to warm it up. It happens with vegetation too. So vegetation change, as it goes from less to more, is actually a positive feedback for climate change, scarily enough. When we look at the hydrological aspect, Erin really wanted to dig into this idea of how do plants transpire and how does the water actually leave the environment from the soil. So we have this term called evapotranspiration. It's actually the largest loss of water to the atmosphere. And Erin wanted to pick apart what are the trees and the bushes doing and what's the rest of the environment doing. So after a few years of measurement, we've kind of realized that plants, they're the linchpin of the whole system. They regulate water loss of ecosystems, and they're all unique. Different shrubs respond differently. Trees respond different than shrubs. We have a really nascent view of how plants really do this. And I think it's going to be something that's going to be probably a few decades of research to fully understand how plants are using water. They're super sophisticated, but shrubs are amazing. They kind of start late. They seem really small, but boy, then they can pump out the water when they have leaves on them. Where trees, they're kind of a bit more responsive. They're a bit slower. They're a bit more zombie-like, but they have a different role. So a lot of Erin's research is looking at these ecosystems and trying to, again, see what the consequences of change is. One of the big consequences is that trees essentially, in vegetation's thermostats, they kind of really are kind of like thermostats. They reduce the variability. They really make ecosystems respond in a more consistent way. As you remove vegetation, you have much more variability. And also as you grow bigger trees and have more of them and more bushes, you get more evaporation and evapotranspiration. So really what's going to happen is that as we green the north, there's actually going to be a lot more water going up. There's probably going to be a lot more water going down. But again, it's really complicated because as you grow vegetation, it really affects precipitation because a lot of the landscape traps snow, and shrubs really trap snow, and trees do. And high elevation, it blows away. And higher on the mountain, there's more rain than lower on the mountain. So this work is fascinating. It's really also looking at what kind of water they use and how this affects the water of the stream. Again, it's going to affect it a lot. We don't really know. The permafrost thaw we get, the vegetation change, this is sort of where a lot of cool research is going to be happening, I think, as we really see what plants are doing, because again, they're what's changing fast. There's lots of other changes that are happening. It's really depressing. There's fire. There's a lot more fire than there was ever in the north. I have a colleague here who's a fire expert, a Canadian fire expert, Mike Waddington, and he's looking at fires across the boreal in northern Canada and trying to understand the processes. Again, no matter where we look, fire is becoming more and more common. There are these zombie fires and peat that burn for years and years and years and smolder, releasing lots of CO2 to the atmosphere. And yeah, so this is just modern pictures of showing that fire risk is really high in the Arctic, again, a consequence of this warming. Mike sent me this picture today. My supervisor was always an artist. Now he does his art in sort of digital form. He's retired, but he gave this to Mike, so I just thought it would be nice to show. Again, just sort of wrapping up here. No matter where we look, we're losing cold. And again, in the north is where we are going to lose it the most. In the Yukon recently, there was a really cool event that there was I must have missed it. Yeah, there was this glacier that sort of melted back and disappeared. And as it melted back, it didn't disappear, but as it melted back, the drainage went from the Arctic Ocean to the Pacific Ocean. They called it river piracy. And there's a fellow prof at Calgary, Dan Sugar, who kind of wrote a lot of really great papers about this, and it's had big consequences. Lakes have dried up, change of water chemistry, as I mentioned, all sorts of stuff. So Gennady was quite taken by this river piracy, and I think that's a scientist pointing water's now going that way. So kind of cool. Yeah. So when we go to the north, we see things we don't know what we're looking at sometimes. It's a lot of strangeness. This is actually an inversion. There's a lot of cold air below and warm air above that cause optical illusions. People from the prairies know what inversions are typically. This is a big inversion. It's probably -40 out, but in the upper atmosphere, it's probably -5. So it kind of have these odd optical processes. We don't spend a lot of time looking at things. I've spent a lot of time, as I say, I'm an old man now, spent a lot of time looking at things. And the one thing, and this is where I'm going to finish it off, which ties into my other career, is that Canada's a funny place. We think we're environmentalists. We all sort of have a concern about the environment, a concern about the water, but we're also a country that's heavily dependent on resources. And I really like this comment by Harold Innes, famous geographer. The trade and staples characterized an economically weak country has been responsible for various peculiar tendencies in Canadian development. And I've been across the north. I've been across Alberta. I work a lot in Alberta as well. And no matter where we go across the north, there's also a large impact of humans. It's a double push. We have human impacts and we have climate impacts. These aren't passive effects. There's drilling fluids that are leaking into lakes. There are sumps. There are lines that are sort of used for geophysical surveys. All of these have really, really, really large consequences on the water in the north, and you really can't contain them because as the permafrost thaws, it leaks. And you probably have heard of Janowicz recently. They had all sorts of drinking water problems, which really is a consequence of thawing permafrost around some of the drums that had been frozen in the permafrost with fuel and now have thawed out and allowed water to leak into their water system, which is a real tragedy, and they're still struggling with it. Mining is massive across the north. Big diamond mines, like they call these. You get a little polar bear on your diamond, massive landscape disturbances that'll be, a long time cleaning up. These are operational mines, but across the north there are abandoned mines. There's a giant mine here in Northwest Territories that has horrible arsenic problems for the environment. One I work on is in Faro. Faro was once the world's largest mine, and people walked away from it. And that used to be the way Canadian mining companies worked before there were bonds. They would work and then close. And they've been working for 20 years and spending lots of money to try to figure out how we restore a system which is leaking horrible amounts of contaminants into the environment. And so we're spending time learning what we have learned at Wolf Creek and at two to do similar type of experiments with industry and the government to try to say, hey, how do we actually rehabilitate a landscape like this in a cold region? How do we grow permafrost? How do we grow vegetation that'll sort of sustain and sort of not be affected by sort of toxic legacies? And again, this is one of our sites, and this is reclamation. There's trees growing back here, and you can always tell we're on a mine site because we have to wear PPE and a hard hat. It's actually staggering. If we look across Canada, there are thousands of abandoned mines, and in the north, if you look in the Northwest Territories, it's unknown the financial liabilities. I've driven around everywhere. There's pocket mines that people have just walked away from, and I've worked in mining long enough to know that legacies of abandoned mines often last thousands of years. There's Roman lead mines in Wales that still have toxic, water quality, and this is sort of what we're in for. If we're, this is what we're in for, and it's going to get worse, not better, with climate change. The one thing is I'm going to end on is just a few comments. I'm just about done, and maybe a minute or two over time, is we understand what we see, and in some ways we see less. When I was a graduate student, things were okay. The federal government had a really large and vibrant scientific community in the north. There were lots and lots of researchers working in the north. Universities were kind of almost second fiddle to the federal government. And since the mid-90s, there's been a consistent and irreversible decline in scientific capacity in the federal government and almost interest in the federal government to do long-term environmental monitoring and research. almost all long-term watersheds and long-term experiments now in the north are run by universities and not by the federal government. This picture is basically the number of stations in the north that the government used to run, and now it's collapsed. And this is all economic and a lack of interest, and people talk about it. And a few years ago, I guess I got old enough to become a bit of an advocate, and we wrote with colleagues across the world, because this isn't just a Canadian issue, to save northern high latitude catchments, just because the money and the cost and the expense to go into this rapidly changing environment is so much, and we've just basically lost or are losing the ability to do this. Long-term data is important. It's science. It's not just monitoring, and there's so many things we can ask and answer. And there's also a lot we can understand by working with Indigenous communities. It's been something over the last 5 or 6 years I've really sort of had a much deeper engagement with. Actually, this woman here is the chief from Fort McPherson. We met with them in the Tombstones this summer, and we were chatting about groundwater and shrubs and the issues that they had in the north, and the perspectives that Indigenous communities have on the environment is beyond ours. And in some ways, we have lots to learn. We have sort of, as Western scientists, we sometimes don't understand what we're hearing. I can think of a number of examples where people were telling me stories and I didn't quite get it. Then later someone said, "You didn't get that." And I'm like, "I do now." And I think it's a really positive thing that we share more as scientists, and we broadly engage broader communities, particularly Indigenous communities in the north and everywhere, honestly, to tell you the truth about the world we live in. The environment is the natural touchstone. It's also important that we communicate. Relationships are everything in science. It's not really about how smart you are or how good your differential equations are or whatever. It's really about talking to people and understanding how your work impacts them, because we all have shared collective solutions to the problems in the world that we have. And it's tragic, it's heartbreaking, but it's also very positive. This was an event we had in the Tombstone Park, and the woman on the left here is a youth Indigenous climate change activist. And we had a couple of events where we talked about different issues, and these were just tourists, and we were just telling them about the issues that we'd seen through the years. And and it was sort of a really great event. I'm going to end it here, or almost here. I've been blessed. I've been blessed that McMaster's allowed me to do this. I've been blessed that a microbrewery opened up in our catchment right at the outlet and has a flight special named after our research basin. So we do a lot of outreach. I have 2 wonderful colleagues. Rick has passed away, and this is John Pomeroy. John is a very celebrity Canadian hydrologist. He's never seen a TV camera he doesn't want to jump in front of. I've never met Greta Thunberg, but he grabbed her and brought her up to his research site on the Athabasca Glacier there. So I figure it's 1 degree of separation, if nothing else, to a big SGD climate activist that most people know. And to all my students, this is just my students now. I really don't do much anymore other than sort of be the DJ. They write the songs, they play the music, and I put the album together. That's essentially all I've become now, as I sort of try to help the next generation of scientists sort of continue what we started a long time ago and sort of come up with the solutions to the future. So I'll leave it at that. I have too many people to thank. And most of this, of course, wasn't mine. It was other things that people did, but hopefully I didn't depress you. I excited you, because I think, there's lots to be done. And again, thanks for showing up. And I guess there's a Q&A now, because I see that, Jessica's shown up. So I should stop sharing my screen, or do I keep the art on? What's the plan?
I think you can stop sharing your screen, but I wanted to say thank you so much for sharing all your research and information with us, as well as the beautiful photos and artwork. It's a beautiful country that we live in, and it's nice to see artwork from that area for those of us who haven't been to that area yet. Hopefully we can go at some point in our lives. So just a reminder that you can ask questions using the Q&A button at the bottom of your screen, and we will have a few minutes to answer some questions. So I do have one here to start, and someone is asking how we can go about reviewing this process.
Reversing this process. You can't, I don't think. I think we're just going to have to deal with it. I think, there's lots of climate goals. I was in Ottawa actually just last week or the week before. It was World Water Day, but it was just before they were releasing the climate action, net zero by XXXY. The effects of climate change are going to play out over the next few hundred years. And things that have happened now in permafrost and the thawing are actually going to play out over the next few hundred years. There's really nothing we can do. We can lower atmospheric temperatures. We can do all this sort of positive things that we should do to reduce emissions. But the die is cast, and we essentially have to understand what's going to happen as they roll on the table and what numbers come up. And hopefully it's not snake eyes. That's really negative. Maybe it's going to be 7.
Someone else is asking, when you say never before, what is your time frame?
Yeah. My time frame's not well, I always get in trouble when I say this to my geology friends. Never before. They're like, Sean, stop talking like that. It's never before in I would say the Quaternary period. So in the last, several thousand years. I mean, of course, none of these things are threatening the planet or anything like that. But in terms of, when peoples inhabited the land and in terms of Canadian history, these things have never been seen. So basically since the last glaciation, which isn't that long ago, it's only 12,000 years ago. That's the context. It's certainly not like, it's like the earth has changed so much over the last, billions of years. It's not even apples and oranges.
I have another question here. How serious is the methane being released by the permafrost melting?
Yeah, I didn't want to talk about this because it's actually very controversial in scientific fields, and I try to keep away from it. It's called the carbon bomb, and you probably have heard about it because as the soil thaws, there's lots of organic material that's really available for microbial activity. And basically in this anaerobic respiration, they create methane. And so people have done back the envelope calculations to say, if the permafrost thaws, we're doomed. It's going from whatever we are now at 400 and something parts per million to like 800 really fast. And it's going to be much greater than humans. There's a lot of controversy. A lot of people think it's not true. The empirical evidence for it's very limited. It's sort of one of these potential scary ideas that people are chasing around that has kind of been backed off, but not totally. And it's going to be a few years before we know. But it's scary. I mean, if it's true, it's scary. And I get asked a lot because it's so scary. People are like, what about the carbon bomb? It just sounds scary. But it's, yeah. So anyway, wait and see, I suppose. This community in terms of environment. Yeah, this is really cool. I'll just tell a little story. I was talking with an Indigenous friend, and we were chatting. He's like, oh, you should talk to this person. And it was an elder. And so I went to see her. And we were just talking. And then she was talking to me about how the sun used to rise and set here, and then it rose and set here, and how the position of the sun was changing, and then through their history when it was changing. And I was just thought, well, this is crazy. Like, like the sun, like there's orbital dynamics, and, I in science faculty and my physicist friends astronomy friends would get really mad at me for talking about this. And then I was out later and they're like, you didn't know what you're talking about, did you, Sean? I'm like, no, I have no idea. And they're like, oh, she's talking about they moved because of climate change. And those are the periods when they'd moved. And I was like, oh. And so when the sun was rising and setting in different spots, it's because that's when the communities moved. And we can go look at tree rings, we can go look at other proxies. But that's a proxy, right? Talking to people, and Indigenous people have an oral history, and an amazing oral history. And whether it be floods, and we have very short hydrometric records. We have records that go back 40, 50, 60 years. And they'll tell us that, no, this isn't really representative of the last 1,000 years. And so there's lots of opportunities like this to have conversations that actually inform us about what we think we know. And that's something that sort of just fascinates me. Interest in the federal government is so true. Yeah, I know a lot of federal government scientists who now work at universities, but oh yeah, policymakers, oh my gosh. This is a big struggle for science, making policy people here. I've been to Ottawa lots of times. I've talked with policy people. This may sound like, I don't know, a throwaway comment, but often they're not scientists. They're very young. They're in their 20s. They sort of went to policy school. They don't really digest the science. I think it's our fault. I think we don't know how to communicate our science effectively and that it matters. And I think I don't get any, I don't know if I get pay raises anyway, but I certainly don't get any pay raises for affecting policy. I'll say I publish all these papers and I got all this money and then I get a medal. If I say, oh, a parliamentarian listened to me, they probably think I had like I don't know, something weird happening to me. So it's hard. And I think that's an area of science that we should put much more effort into, is having all scientists, not just environmental scientists, tell people how their work should affect policy, because a lot of policy is made decisions that just don't make sense to me, or there's not policy where there should be. So it's a huge thing. It's when someone says policy, I'm like, I go a little crazy. All right, interglacial period, oceans are 8 to 9 meters higher than today. We're now in interglacial period, so why should we be surprised glaciers are melting? I don't know. I guess we should be. I don't think anything's a surprise, right? So I think when people talk about the environment, and it's like, I think we know what's going on. I mean, we have very good geophysical models of the planet, of the ice, of accumulation. I don't think that anything that's going on right now is an environmental surprise. What I think the surprise is that we are doing it and living it. We're conducting a natural experiment, a single natural experiment to the planet, and watching what's happened with a level of detail that proxy records never allowed. And as I say, there's very few things that surprise me in earth sciences and at all. And I think we know what's going on. Sometimes things are fast, sometimes things are slow, but to me, the only real surprise is humans and how we behave and how we watch the train run down the track and we just stay on the train. And it's kind of fascinating to me. All right.
I think this will be our last question.
All right. I'll just read Wes's question here. Are the changes
Perfect.
causing new species to move in the north? I relate your message to shrubs. Yeah. There's a huge migration of, I didn't talk about this, but it's a big issue. There's a huge change in the species that follow the change in vegetation. In Whitehorse, for example, when I first arrived, there was no deer. There's no deer in Whitehorse. Like they didn't even have tags for them. There's changing kind of, like, they always had like certain types of cats, but bigger cats are coming north. Caribou migrations have changed, herds have changed. Yeah, I mean, it's amazing how that also affects Indigenous communities because who typically harvest food from the land, and it's all changing. And it's not necessarily fast, but yeah, I don't really deal with anything that sort of with two legs or that crawls around or I can squeeze or kill. But it's changing just as much. And it's, again, that's something when you talk to Indigenous people who care deeply about the animals on the land because they get so much country food that's often what they want us to study. And we're like, we're hydrologists, we can't study caribou. And they're like, okay, we want more people studying caribou. And there are lots, but it's pretty cool.
Well, that's great. Thank you so much for sharing all your information and research with us this evening. And again, those photos and artwork, getting lots of comments in the chat about how beautiful they are. So thank you very much for taking the time out of your schedule to share your talk with our group this evening.
All right. Thanks everyone for listening and thanks for having me. I very much appreciate it as an alumni. Go McMaster.
Thank you. And following the webinar, our viewers receive an email to a quick survey. If you could kindly take a few minutes to fill it out, we appreciate the feedback. And for more information on all of our upcoming events, please visit our website at alumni.mcmaster.ca/events. And thank you once again for joining us this evening. Have a great evening.
Bye, everyone.